I'm letting her in.
Okay, file.
Oh, let me just
Hello.
hi Lauren.
Lauren.
Hi, everybody. Hi, Kelly. Hi, Diego. Hi, Cindy. Hi, Jen.
Can you hear that I have a fan on in the background?
No, actually,
Okay, good.
No.
you look very handsome. Did you get your hair cut?
Oh, thank you. No, I didn't, but I think I just took a shower.
You clean up well, kid.
Thank
Yeah,
you.
you do.
Thank you.
Are you back at home? You have a nice blue wall behind
Yes,
you.
I am back at home. This is my room.
Welcome back.
Thank you.
Did you have a good holiday?
I did. I saw
Okay.
lots of really cool birds and a coral reef, which was amazing.
Whoa.
Wow. What's this thing?
I saw so many fish that I had never seen before. And my brother and I, we saw a really huge reef shark. Like it was so close to us.
Really?
Wow.
Yeah.
How magical.
Yeah, it was amazing.
Were you scared?
Where were you, Diego?
For a second, I was in Florida, in the Florida Keys.
Yeah.
Okay.
Yeah.
Nice.
We went snorkeling in John Pennycamp State Park.
Hmm?
So Diego, if you can believe it, has a brother who's as passionate as he is about birds, about fish.
Yeah, that's what
Oh
it's.
my.
Cool.
So they, in one family unit, are covering the creatures of the sea and the creatures of the air.
Yeah. Kelly, I opened this file, but it's telling me it's empty. Maybe I can do something else.
Okay, should I just email it to you?
Oh, here, let me look. There's an option to open it a different way. Let's see. Yeah, no, it's not working.
Okay, I'm gonna email
Yeah,
because
just
I think
emailing
it might
would be
be
better.
too big for.
Can you hear me?
Yes.
My computer is doing this thing that it does sometimes where I have to restart the whole thing. Otherwise it like freezes all my applications. I'm gonna do that really quick and then join back.
Okay, no
Okay,
worries.
Diego, I just emailed you, buddy. You
Okay,
should
thank
have
you.
that one.
All right, I'll be right back.
Okay, we'll be here.
Good luck.
Thank you. Oh, technology.
Lauren, so the fire scare was okay and everybody's safe?
Yeah, it was super stressful, but they got it out. They contained it to 20 acres, but
Oh, good.
it's just like,
It's super stressful.
it's
Oh
just
my
this
God.
constant sort of, you can never be off your guard, you know what I
Yeah.
mean? It's
Yeah.
just, so, it wasn't my best moment.
Yeah, I understand. Yeah.
How's your mom, Cindy?
You're muted, Cindy.
Oh, sorry. I'm sorry. What was that?
How's your mom? Is she stable?
It is. It's just a really slow. I mean, so slow. Her recovery's so slow. We just found out her liver is not good, so now she has cirrhosis, and she just started physical therapy. She doesn't really walk. She can't be left alone.
Oh.
So is the cirrhosis from the medication that they gave her to try and keep her alive?
I think it. I guess she had a fatty liver, and with all the medication and with like all the trauma that she had, it really put an impact or a strain on her already weak liver, and so now she's like filled with fluid all the time, and it's a lot. I don't know how she's doing it, and it's tough.
I'm sorry.
But she's I mean, she's here.
She's here and there's always the possibility of recovering.
Yeah.
So
Thank you.
you're welcome. I'm sorry that you're all going through this.
Thank you.
Life.
I know, deep
Yeah.
breath. I know, life.
I mean, honestly, I don't know what, like another place that I could be in my life right now that would allow me to spend the time that I do with her. So, thank you for allowing me to
Oh,
care
of
for her.
course, of course. You know how I feel about taking care of our elders.
Yeah, thank you.
Everything always gets done somehow. I mean,
Yes, it really does.
It is. It's like if we plan an event or we have anything happening, we're scrambling the last minute, but in the end, it's beautiful and nobody knows that that any of us was stressed.
yeah, I think it's the nature of the future workplace is that people have to be able to live their lives and productivity has to be shaped around that. I mean, people have to take care of their parents, people have to take care of their pets, people have to take care of their lives, people have to take care of themselves. And somehow everybody still finds enough time to get what they need to get done. I mean, I
Yeah,
just got to trust it.
true.
Oh, Diego's back. I'm gonna let him in.
Okay. Welcome back.
Hi, Diego.
Okay, I'm all better now, and I have the marked reading.
Woohoo! And it's showtime.
Okay, I'll start letting everybody in.
Excelente.
Hello, everyone, and welcome. The Metabolic Studios Learning and Mending series is now in its 5th iteration. In this series, from micro to macro, we will be exploring the implications of an integrated forms of systems thinking that allows us to think across scales, from particle, cell, brain, society, ecosystem, to cosmic matter. From micro to macro, we'll build upon what we learned about from Anna Singh's disturbance ecology and have an emphasis on complexity, networks, and patterns of organization. Many of you have received embroidery kits from us of native plants, birds, and microscopic organisms that Metabolic Studio is currently cultivating on its project sites. Taken as a collection, all the embroideries will collectively illustrate biogeocoenosis, which describes the intimate association between living things and the physical environment. If you've not received an embroidery kit and would like another one, please send your name and mailing address to info@metabolicstudio.org. We will share our screen and we encourage you to read a section of the text aloud with us. When there is a pause in the reading, please feel free to unmute yourself and begin where the last person left off. Silence is golden, and there is no pressure to fill the transitional spaces while we enjoy a breath and continue crafting. Feel free to jump in and continue reading at your comfort level. You don't have to read, it's also fine to enjoy listening. And I would like to start tonight by sharing with you all the embroidery of the week. And this one is from one of our own Metabolic Studio team members. This is Olan Jones. So we are building up our bird collection, and I have to tell you, this is extraordinary. I love the use of color, the texture, and as always, I just want to let you all see the back and its perfection, which I am still, after a year and a half, trying to get a back that looks as beautiful as this.
Well, thanks. I object.
Well, will you please share with us
It looks beautiful.
your color selection?
Well, the thing is that I love about doing this embroidery is that it's sort of like slow motion painting, where you have one idea and you start in with that, and then as you're listening, as you're putting the needle in and out, you think of, well, maybe a green. No, no, not the green, the blue. Yes. And there's time to just make your ideas come to life in that way without, you know, painting over the canvas again. You can just keep going slowly.
It's extraordinary. And also, I just want to say how much I love the lettering. You get extra points from me if you actually do the lettering. Some have come back without lettering, and I just love the lettering. So this is our embroidery of the week, and now I will pass it over to Kelly, and she will introduce the authors and the guiding question.
Great, thanks, Jen. That's so beautiful, Olan. So we're continuing our journey into systems thinking tonight. Our readings tonight will talk a bit more about networks and some about cellular metabolism, which is cool because it goes along with our embroidery theme. We'll have some nice imagery in that one. And these readings are continuing from the Systems View of Life, written by Fritjof Capra, and The Tree of Knowledge by Varela and Materano. These authors, as I mentioned last week, are well-known systems thinkers and philosophers, and make up a lot of what we're reading in this series. But tonight we also have a reading from a lady named Diana Beresford Kroger. And she's really interesting. She's a world-recognized author and a medicinal biochemist, botanist, and climate change visionary. She's based in Ireland and really influenced by Celtic culture. And she's doing this great project where she's trying to preserve the genetics of really ancient tree species and going and really paying close attention to old growth and the knowledge embedded in its genes and DNA. So really interesting lady, and we have a reading from her tonight as well. And so a couple of guiding questions. I'll put these in the chat, but I'll also put them up at the end. And these are just, food for thought, just to spark the ideas. But of course, when we have our discussion, it's an open discussion too. These are just to give us something to think about. The first one I came up with was, what does the idea of metabolism bring up for you? Does a city have a metabolism or a forest? And how would you define metabolic processes? I've been contemplating metabolism myself lately and how it's such a connecting force in the world. So wanted to put that out there. And then the second one I had is around disturbance, and what examples of disturbance to a network system are beneficial, and what examples of disturbance are detrimental, and what makes up the difference. So I will put these in the chat, and like I said, you don't have to remember them because I'll put them up at the end as well when we have a chance to talk. And now I will pass it back to Jen for her time lapse, right?
Yes, I will be sharing tonight a quick little time lapse video of this really neat technique that we found, and never would have thought to do these stitches like this. So let me share the screen with you now. And here we go. Sorry about that.
Yay.
And now we can begin our reading.
Okay, take it away, Diego.
Hey, wait, Jen, can you put that in the chat bar too? So if any of us want to.
Of course. Yep, I'll do it right now.
I can start us off. A new way of thinking. The ideas set forth by organismic biologists during the first half of the 20th century helped to give birth to a new way of thinking in terms of connectedness, relationships, patterns, and context. According to the systems view, the essential properties of an organism or living system are properties of the whole, which none of the parts have. They arise from the interactions and relationships between the parts. These properties are destroyed when the system is dissected, either physically or theoretically, into isolated elements. Although we can discern individual parts in any system, these parts are not isolated, and the nature of the whole is always different from the mere sum of its parts. The system's view of life is illustrated beautifully and abundantly in the writings of Paul Weiss, who brought systems concepts to the life sciences from his earlier studies of engineering and spent his whole life exploring and advocating a fully organismic conception of biology. The emergence of systems thinking was a profound revolution in the history of Western scientific thought. The belief that in every complex system, the behavior of the whole can be understood entirely from the properties of its parts is central to Cartesian paradigm. This was Descartes' celebrated method of analytic thinking, which has been an essential characteristic of modern scientific thought. In the analytic or reductionist approach, the parts themselves cannot be analyzed any further except by reducing them to still smaller parts. Indeed, Western science has been progressing in that way, and at each step there has been a level of fundamental constituents that could not be analyzed any further. The great shock of 20th century science has been that living systems cannot be understood by analysis. The properties of the parts are not intrinsic properties, but can be understood only within the context of the larger whole. Thus, the relationship between the parts and the whole has been reversed. In the systems approach, the properties of the parts can be understood only from the organization of the whole. Accordingly, systems thinking does not concentrate on basic building blocks, but rather on basic principles of organization. Systems thinking is contextual, which is the opposite of analytical thinking. Analysis means taking something apart in order to understand it. Systems thinking means putting it into the context of a larger whole.
Cool, I can take a turn here. Gestalt psychology. When the first organismic biologists grappled with the problem of organic form and debated the relative merits of mechanism and vitalism, German psychologists contributed to that dialogue from the very beginning. The German word for organic form is Gestalt, as distinct from form, which denotes inanimate form. And the much discussed problem of organic form was known as the Gestalt problem in those days. At the turn of the century, the Austrian philosopher Christian von Arfenfels was the first to use Gestalt in the sense of an irreducible perceptual pattern, sparking the school of Gestalt psychology. In the subsequent decades, the Anglo-Saxon followers of this new discipline would continue to use the term Gestalt as an English technical term to denote the irreducible perceptual pattern. Ehrenfels
characterized a gestalt by asserting that the whole is more than the sum of its parts, a statement which would become the key formula of systems thinkers later on. Ecology. While organismic biologists encountered irreducible wholeness in organisms and Gestalt psychologists in perception, ecologists encountered it in their studies of animal and plant communities. The new science of ecology emerged out of the organismic school of biology during the late 19th century, when biologists began to study communities of organisms. Ecology, from the Greek oikos or household, is the study of the earth household. More precisely, it is the study of the relationships that interlink all the members of the earth household. The term was coined by the German biologist Ernst Haeckel, 1919, who defined it as the science of relations between the organism and the surrounding outer world. The word Umwelt, environment, was used for the first time by the Baltic German biologist and ecological pioneer Jacob von Uexküll in the 1920s. Ecologists focused on functional relationships within the animal and plant communities. In a pioneering book, Animal Ecology, Charles Elton introduced the concepts of food chains and food cycles, viewing the feeding relationships within biological communities as their central organizing principle. Since the language of early ecologists was very close to that of organismic biology, it is not surprising that they compared biological communities to organisms. For example, Frederick Clements, 1874 to 1945, an American plant ecologist and pioneer in the study of succession, viewed plant communities as superorganisms. This concept sparked a lively debate, which went on for more than a decade until the British plant ecologist A.G. Tansley, 1871 to 1955, rejected the notion of superorganisms and coined the term ecosystem to characterize animal and plant communities. The ecosystem concept, defined today as a community of organisms and their physical environment interacting as an ecological unit, shaped all subsequent ecological thinking, and by its very name, fostered a systems approach to ecology. The term biosphere was first used in the late 19th century by Austrian geologist Edward Suaus. I'm really screwing up the names. 1831 to 1914, to describe the layer of life surrounding the Earth. A few decades later, the Russian geochemist Vladimir Vernadsky, 1863 to 1945, developed the concept into a full-fledged theory in his pioneering book, Biosphere. Vernadsky saw life as a geological force, which partly creates and partly controls the planetary environment. Among all the early theories of the living Earth, Vernadsky's comes closest to our contemporary Gaia theory. Also see Margulis and Sagan, 1995.
I can take over. Ecological communities. The new science of ecology enriched the emerging systemic way of thinking by introducing two new concepts, community and network, by viewing an ecological community as an assemblage of organisms bound into a functional whole by their mutual relationships. Ecologists facilitated the change of focus from organisms to communities and back applying the same kinds of concepts to different system levels. Today, we know that most organisms are not only members of ecological communities, but are also complex ecosystems themselves, containing a host of smaller organisms that have considerable autonomy and yet are integrated harmoniously into the functioning of the whole. So, there are three kinds of living systems: organisms, parts of organisms, and communities of organisms, all of which are integrated wholes whose essential properties arise from the interactions and interdependence of their parts. The network concept. From the beginning of ecology, ecological communities have been seen as consisting of organisms linked together in network fashion through feeding relations. This idea is found repeatedly in the writings of the 19th century naturalists, and when food chains and food cycles began to be studied in the 1920s, these concepts were soon expanded to the contemporary concept of food webs. As the network concept became more and more prominent in ecology, systemic thinkers began to use network models at all system levels, viewing the organisms as networks of cells, organs, and organ systems, just as ecosystems are understood as networks of individual organisms. Correspondingly, the flows of matter and energy through ecosystems were perceived as the continuation of the metabolic pathways through organisms. The viewing living systems as networks provides a novel perspective on the so-called hierarchies of nature. Since living systems at all levels are networks, we must visualize the web of life as living systems, networks interacting in network fashion with other systems. Networks. For example, we can picture an ecosystem symmetrically as network with a few nodes. Each node represents an organism, which means that each node, when magnified, appears itself as a network. Each node in the new network may represent an organ, which in turn will appear as a network when magnified, and so on. In other words, the web of life consists of networks within networks. At each scale, under closer scrutiny, the nodes of the network reveal themselves as smaller networks. We tend to arrange these systems, all nesting within larger systems, in hierarchical scheme by placing the larger systems above the smaller ones in pyramid fashion. But this is a human projection. In nature, there is no above or below, and there are no hierarchies. There are only networks nesting within our networks.
And then that's where we're going to stop with this reading, Diego, so we can move on to a reading from Diane.
I'll read some. Red and green of the forests are the basic symbols of life, bloodlines. Red and green have been mystical colors since ancient times. These colors were symbols for the human race long before written language. Red and green were the colors of the warrior Celts who stamped across Europe into battle naked, while at home the cult of their druidic priests plied their sacred image in prayer. In the end, colors are like names. They are carried in the mind. Their visual simplicity allows them to be retained deep in memory. the colors red and green ride the tides of civilization with instant recall. They net in their meaning and symbolism intact to be fed as advertising bait into our modern techno times. There is in the global garden a very well-known tree. It is holly, Ilex acifolium, an evergreen of Europe, Africa, and China. It has a deciduous cousin in North America, I. verticillata, winterberry, as well as the evergreen holly, I. opaca. They are all important medicinal trees being used in the management of elevated fevers. The Druids had long adopted the holly for their pagan festival of light and darkness, which comes down to us today as Christmas. During the season of Christmas, holly is now transported all over the globe. Since its old name is holy plant, it fits in with the birth of the Christ child. This species, with its forest green leaves and tight cymes of blood red berries, is used to decorate homes for the Christmas holidays. Even the Christmas pudding is somewhat surprised to find itself ablaze with its top knot of holly, all an echo of those pagan times. Holly is that mystical plant of green and red. In times past, the deep color represented the green of the ancient virgin forests and all of the secret powers that they held. These were considered to be holy places, and for many still are. Holly achieves its forest green color by a trick of optics. The upper layer of the leaves has a waxy film that amplifies the color and gives it an optical depth. For the Druids, the berry color is exactly that of fresh blood, that particular scarlet of sacrifice, human, of course. In addition, to the Celts, red and green represented the dichotomy of our lives. It was true then, and it is true now. The forest green represents the plants that serve us and give us sustenance for life, and red is the deep limbic knowledge of self, the circulation and the blood that flows through us. Both systems of man and forest depend on each other. The symbolism and perhaps even the mysticism of red and green originate at a molecular level. Blood is a red pigment that functions like an oil. It is primarily made up of flexible, mobile hemoglobin molecules contained in donut-shaped sacs, the red blood cells. It has genius in its design, and this design is shared in a remarkable way by the green, oily pigment of plants, chloroplasts. The chloroplasts are also sacs containing the flexible, mobile chlorophyll molecules. These two sister molecules, hemoglobin and chlorophyll, the red and the green, conduct the pattern of our lives. Without them, we would not survive as a species or as a planet.
But there is more to the molecular story. Both hemoglobin and chlorophyll are molecular machines. They work in a similar manner, almost as if they were related to each other, which they are in a wider global sense. Their family kinship is built on the design they have in common: 4 aromatic rings that contain nitrogen. Sitting in the center position of these rings, like a solitaire diamond, is an atom of metal. In attendance to this metal, holding it in place like a diamond in its setting, are the 4 nitrogens of the 4 rings. The nitrogens hold an atom of iron in the case of hemoglobin molecule. The nitrogens hold an atom of magnesium at the center of the chlorophyll. Both of these metals, the iron and the magnesium, present 2 faces to the world, and these 2 faces operate like a quantum clock that tick-tocks with the time. In one quantum state, both metals are loaded with incoming electron energy. They tick into one valence. And in the other quantum state, the metals unload and they talk into a second valence. Both metals, when held by nitrogen, tick-tock for all their working life in a quantum state. This is how oxygen is passed into the hemoglobin molecule that sits inside its donut sac. This is how oxygen gets into every tissue of the body to bathe it with a kiss of its life. And this is how oxygen gets delivered from the chloroplast sacs in the mesophyll of the leaves of all plants and trees. Mesophyll is the tissue that opens up into the breathing pores or stomata of a leaf. This tissue is the flexible carrier bag for chloroplastic sacs. It is surrounded by air spaces. These air spaces are open to the atmosphere for gas exchange. This too is how oxygen is delivered into the atmosphere, into the oceans, and the soils of the world for all of the aerobic life forms within these systems. It seems like part of a divine plan. These twin sister molecules working hand in hand in their quantum homes to forge life for the entire planet. So what is old is new. Red and green have been mystical colors since ancient times. What is new is the story that these colors hold for the human race. But like the old, their importance goes beyond human language and the written word into the mystical Celtic conundrum of the question of meaning of wisdom itself.
Great. And we have those molecules here for our visual, for a visual encounter. Chlorophyll on the bottom and hemoglobin on the top. Of course, they're representations, but they're kind of fascinating to see. Now we can move on to our next reading, which might be the most challenging, but we're gonna see what comes out of it.
I think it accidentally closed. I'll just pull it up really quick. When we speak of living beings, we presuppose something in common between them. Otherwise, we wouldn't put them in the same class we designate with the name living. What has not been said, however, is what is that organization that defines them as a class? Our proposition is that living beings are characterized in that, literally, they are continually self-producing. We indicate this process when we call the organization that defines them an autopoietic organization. Basically, this organization comes from certain relations that we shall outline and view more easily on the cellular level. First, the molecular components of a cellular autopoietic unity must be dynamically related in a network of ongoing interactions. Today, we know many of the specific chemical transformations in this network, and the biochemist collectively terms them cell metabolism. Now, what is distinctive about this cellular dynamics compared with any other collection of molecular transformations and natural processes? Interestingly, this cell metabolism produces components which make up the network of transformations that produce them. Some of these components form a boundary, a limit to this network of transformations. In morphologic terms, the structure that makes this cleavage in space possible is called a membrane. Now, this membranous boundary is not a product of cell metabolism in the way that fabric is the product of a fabric-making machine. I can go back and read the red box too, or we can skip that.
Yeah, I think the way it works best is to go ahead and finish this, paragraph reading until a natural end, and then we can go back and take a pause and read that inset maybe?
The reason is that this membrane not only limits the extension of the transformation network that produced its own components, but it participates in this network. If it did not have this spatial arrangement, cell metabolism would disintegrate in a molecular mess that would spread out all over and would not constitute a discrete unity such as a cell. The origin of organic molecules. In a discussion of the origin of organic molecules comparable to those found in living beings, such as nucleotidic bases, amino acids, or protein chains, there is often the temptation to think that there is little likelihood of their spontaneous appearance and that some guiding force is required in the entire process. From what we have outlined, this is not so. Each one of the stages described arises as an inevitable consequence of the previous one. Even today, taking a sample of the primitive atmosphere and energizing it adequately would produce organic molecules similar in complexity to those found in living beings. Even today, sufficiently compressing a gaseous hydrogen mass would produce thermonuclear reactions in it that give rise to atomic elements not present before. The history that we have been outlining is one of sequences that invariably follow one after the other, and a result would be surprising only to a person unfamiliar with a complete historical sequence. A classic piece of evidence that there is no discontinuity in this transformation by stages was given in an experiment that Miller did in 1953. See figure 11. Miller's idea is simple. Put inside a laboratory bottle an imitation of the primitive atmosphere as to composition and energy radiations. Apply an electric discharge to a mixture of ammonia, methane, hydrogen, and water vapor. The results of the molecular transformations are collected by circulating water inside the bottle, and the substances that remain dissolved there are analyzed. To the surprise of the entire scientific community, Miller was able to produce abundant molecules typical of modern cellular organisms, such as the amino acids alanine and aspartic acid, and other organic molecules such as urea and succinic acid. And here's the experiment. The next part is this, what we have then.
What we have then is a unique situation as regards relations of chemical transformations. On the one hand, we see a network of dynamic transformations that produces its own components, and that is essential for a boundary. On the other hand, we see a boundary that is essential for the operation of the network of transformations, which produced it as a unity. So there's the diagram with dynamics and the boundary. Note that these are not sequential processes, but two different aspects of a unitary phenomenon. It is not that first there is a boundary, then a dynamics, then a boundary, and so forth. We are describing a type of phenomenon in which the possibility of distinguishing one thing from a whole, something you can see under the microscope, for instance, depends on the integrity of the processes that make it possible. Interrupt at some point the cellular metabolic network, and you will find that after a while, you don't have any more unity to talk about. The most striking feature of the autopoietic system is that it pulls itself up by its own bootstraps and becomes distinct from its environment through its own dynamics in such a way that both things are inseparable. Living beings are characterized by their autopoietic organization. They differ from each other in their structure, but they are alike in their organization. By realizing what characterizes living beings in their autopoietic organization, we can unify a whole lot of empirical data about their biochemistry and cellular functioning. The concept of autopoiesis, therefore, does not contradict these data. Rather, it is supported by them, it is explicitly it explicitly proposes that such data be interpreted from a specific point of view, which stresses that living beings are autonomous unities. We use the word autonomy in its current sense, that is, a system is autonomous if it can specify its own laws, what is proper to it. We are not proposing that living beings are the only autonomous entities. Certainly they are not. But one of the most evident features of a living being is its autonomy. We are proposing that the mechanism that makes living beings autonomous systems is autopoiesis. This characterizes them as autonomous systems.
The question about autonomy is as old as the question about living. It is only contemporary biologists who feel uncomfortable over the question of how to understand the autonomy of the living. From our standpoint, however, this question is a guideline to understand the autonomy of living beings. To understand them, we must understand the organization that identifies them as unities. Being aware that living beings are autonomous unities helps to show how their autonomy, usually seen as mysterious and elusive, becomes explicit. For we realize that what defines them as unities is their autopoietic organization, and it is this autopoietic organization that they become real and specify themselves at the same time. Our intention, therefore, is to proceed scientifically. If we cannot provide a list that categorizes a living being, why not propose a system that generates all the phenomena proper to a living being? The evidence that an autopoietic unity has exactly all these features become evident in the light of what we know about the interdependence between metabolism and cellular structure. That living beings have an organization, of course, is proper not only to them, but also to everything we can analyze as a system. What is distinctive about them, however, is that their organization is such that their only product is themselves, with no separation between producer and product. That being and doing of an autopoietic unity is inseparable, and this is their specific mode of organization. Like any organization, autopoietic organization can be attained by many different types of components. We have to realize, however, that as regards the molecular origin of terrestrial living beings, only certain molecular species probably possess the characteristics required for autopoietic unity, thus initiating the structural history to which we ourselves belong. For instance, it was necessary to have molecules capable of forming membranes sufficiently stable and plastic to be, in turn, effective barriers and to have changing properties for the diffusion of molecules and ions over long periods of time with respect to molecular speeds. Molecules from silicon layers, for instance, are too rigid for them to participate in dynamic unities, cells, in an ongoing and fast molecular interchange with the medium. It was only at that point in the Earth's history when conditions were right in the forming of organic molecules such as proteins, which have enormous complexity and pliancy, that conditions were right also for the forming of autopoietic unities. In fact, we can assume that when all these sufficient conditions were present in the Earth's history, autopoietic systems formed inevitably. That moment is the point we can refer to as the moment when life began. This does not mean that it happened in one instance or in one place only, nor can we specify a date for it. All the available evidence leads us to believe that once conditions were right for the origin of living systems, they originated many times. That is, many autopoietic unities with many structural variants emerged in many places on the Earth over a period of perhaps millions of years. And I'll read the insert here, cells and the membranes. The cell membrane plays a more sizable and varied role than that of a simple line of spatial demarcation for a number of chemical transformations. Because it participates therein like other cellular components, this takes place under circumstances in which the cell interior has a rich architecture of large molecular blocks, through which pass many organic species in continuous exchange, and the membrane is operationally part of that interior. This is true for the membranes which limit the cellular spaces and that adjoin the exterior medium, and for those membranes which limit each one of the different internal spaces of the cell. See accompanying figures. This interior architecture and cell dynamics are complementary features of cellular autoposis.
Great, I think that concludes the readings that we had set up. Diego, were you gonna take us back and take a quick look at that diagram and
Yeah.
try to digest? This reading is a little challenging, so we thought we might go back and see what we can do.
Is my screen frozen for anyone else, or is it just my screen that shows it like that?
No, it's
okay. Okay, good. So yeah, this diagram here is showing how the membranes of cells are both responsible for creating the internal composition and structure of the cell, and are themselves part of that composition and structure. So the idea of autopoiesis in this case is basically saying that neither of this creation of the demarcation of the system and the constituting of the system itself are occurring simultaneously. And this pattern, this kind of structure of organization, you see at which you would expect, you see it at every level of systems that involve organisms and their relationships. You see it in, for example, a morphological and behavioral level in organisms that encompasses lots of these circuits that are simultaneously constituting and demarcating themselves.
So
An example.
I'm sorry to interrupt, but I think we are seeing the wrong page. Are you looking at the diagram of the cell with the membrane on it? Because we're seeing at least I am seeing the dynamics boundary membrane metabolism diagram.
Yeah, that's the one that I'm.
Okay, I'm sorry.
You want to see another one?
No, I love that diagram of the cell on the previous page, and I thought you were talking about, wait, no, I think it was another one. Never mind. I'm sorry to interrupt.
No, it's okay.
That one.
This one, yeah. So this is showing the that pattern of the membrane with the internal parts that they're both constituting one another. And what I was going to mention was that you see the same pattern at the level of morphology that encompasses all of the cellular processes that make up an organism, and behavior, to where you have an animal like, let's say a seed-eating bird, or it could be really anything, but you have an animal that the morphology determines the kind of behavior and the kind of metabolic processes and the kind of actions that characterize that organism, where, for example, with the bird, you have a bill that allows them to eat only a certain set of foods or a certain kind of food, or live in a certain set of conditions. And that determines the behavior of the organism, where they're seeking out those kinds of foods, or they're behaving in that set of conditions. And then that is responsible for constituting the actual morphology and the cellular composition of the organism. And you can kind of see an emergent property that comes out of this dynamic, which is that you have basically what you could call the consciousness, or the awareness and the perception and behavior of the organism, which is simultaneously constituted by the set of interactions that it's capable of having, and the set of metabolic processes that it's capable of propagating or that keep it going, that filters out, like the cell membrane, products, whether they're nutrients or whether they're experiences that this organism can have. And in that sense, that at the same time is responsible for dictating the behavior and the awareness and what they are able to perceive. So, I mean, you can follow this out to the ecosystem level as well, where you have, like the previous reading mentioned, you have systems that are, whose constituent parts are always creating the boundary and creating acting as a filtering mechanism for the kinds of relationships that can enter and be part of and make up that system. With the caveat that basically all of this is subject to going off in another direction, or opening up some kind of new permeability in the membrane or the filter, whether it's an actual cell membrane or the behavior of an organism or the behavior of a system, an ecosystem, to where you get new and radical changes in a certain direction that change the entire composition of the system. And I think that's the idea that disturbance ecology brings to this, which is that these things are not static. They are characterized by a unity, but that doesn't mean that the unity is immutable or unchanging. It always has the potential to evolve and be shaped by new conditions and relationships.
That was really helpful. Thank you, Diego. I love how you connected it to different scales too, beyond the cell. Because I personally actually struggled with this reading and the concept of autopoiesis, and I know how important it is in systems thinking. So,
Kelly, can you talk a little bit about our conversation about sympoiesis instead of autopoiesis, and the idea of this writing being 40 years old and what some of the current thinking is?
Totally, yeah. So Lauren and I took a look at the reading, and we were both kind of scratching our heads thinking, okay, autopoiesis, self-making autonomous units, as this key understanding of what makes life is in later years, because like Lauren mentioned, this was 30, 40 years ago when this was laid down, people have started to realize how within a cell itself, other organisms, like mitochondria and things, are living within it. And so this idea of, autopoiesis, self-making, has been questioned by philosophers such as Donna Haraway, which many of you may know of. And she coined the term sympoiesis, which is actually making with. And she argues that, Lynn Margulis, who was a very famous biologist who first pointed to the fact that evolution is driven by symbiosis and this kind of embedding of organisms within organisms. If Lynn had coined a term, she would have probably called it sympoiesis, as opposed to autopoiesis, making with. And so, yeah, so it's interesting because I think some of these foundational concepts are being expanded on and pushed and rethought as they should be. And I went down a whole rabbit hole. I was finding all these, other readings, and I thought about sharing it with you guys, but then it would have just been more confusing because it's also complicated, like the layers that Donna, yeah, great. Thanks, Izzy, for that. Donna Haraway does in her book with Staying with the Trouble, is exactly, there's a whole chapter on sympoiesis where she questions it. So yeah, so things are evolving and being questioned as they should be. But the autopoiesis, I do know that it's been a foundational way of understanding the unique characteristics of what makes life different than non-living entities. And so I don't think it needs to be thrown out, it just needs to be expanded on and in new directions. It's kind of how I felt at the end of my rabbit hole journey. That's how I, that's where I came to. So now we can look at our guiding questions and just hear people's reflections and responses to these readings. And we have our beautiful artwork. Lauren Goron is the way you pronounce his name, who put our
Yes,
art?
yes.
Yes, he's making these great diptychs that you guys may have seen on social media. This one, of course, you can see the network structure in the leaf and in the city simultaneously, and just that repeated network that you find in all different forms. So today's guiding questions are, what does the idea of metabolism bring up for you? Does a city have a metabolism, a forest? And how would you define metabolic processes? I think I actually looked up what the definition for metabolism is, and it's a series of chemical reactions that allow for living things to continue or something. But I feel like that definition can be expanded at all different scales of different network types and beyond single organisms. And then the other one, just connecting with the disturbance idea and what, examples of disturbance to a system are beneficial, which we know there definitely are some, and then what are more detrimental, and what is it that makes those differences, which might kind of build on the Anna Singh readings from last series too. But
Yeah,
these
so
are
just to jump in for a minute to clarify disturbance ecology, maybe for people who weren't part of the Anna Tsing Mushrooms at the End of the World, What Lies in the Ruins That Capitalism Has Made. She is using the word disturbance in connection to disturbance ecology to refer to mostly natural events, like when there's an earthquake or a flood or a lightning strike that burns a forest, and how these disturbance events create the possibility for maximum biodiversity. So she doesn't put like a human emotional spin on the idea of disturbance, but she also doesn't exclude that. So with things like disturbance ecology, that might also include, for example, the Fukushima meltdown, right, as being a disturbance event. So I just wanted to clarify disturbance in the context of our conversation. Well, I'll jump in. For me, I define metabolism in a kind of textbook way as having two basic component parts: the anabolic and the catabolic. And the anabolic refers to things being built up, and the catabolic refers to things being torn down. And these are necessary cycles for all living systems. So for me, the metabolic studio, for example, is about thinking about how we can intervene in cycles of the anabolic or the catabolic to especially to reconnect what I would call regolith, or things not capable of being in that metabolic cycle, back into that process. So an example of that might be taking, piercing the tarmac of a tow yard and removing the asphalt and the base and letting light and water touch the earth again. That would be a simple example of a metabolic, what I call a metabolic sculpture, where the object is not the final result of a sculptural process, but the performance of reconnecting something that's not that where the metabolic process has been ground down to an almost halt. I won't say it's a complete halt, because life is abundant and it will always find some kind of way of finding a little cut in a sidewalk to pop right up again. You can go along the LA River and see entire trees growing out of cracks in the concrete. So, life has a way of finding an opportunity, but it's easy for me to sort of look at metabolic cycles and things around me as being able to see, whether it's being built up or torn down as part of the cycle of life.
Lauren?
Yeah.
You used a word, I think it was regolith?
Yeah, regolith.
With a G, like regolith?
Yeah.
What does that mean?
I know it's a weird word, but I like it. It means something incapable of supporting life.
Okay, cool.
Lith is a Greek for like stone, and I'm not sure what the rego part is, but
Okay.
but yeah, it's usually refers to something ground down to a halt. I mean, sometimes in urban planning that can be called a brownfield, but it has to do with a certain kind of metabolic inertia. Things aren't moving.
Things aren't working. Right.
Yeah.
Cool. I've never heard that. I like that idea. I also wanted to ask, I came in a little late, unfortunately, and I missed a little bit, but I wanted to question the idea that was brought up in the second text reading that had to do with the gist I got, and I'm questioning if anyone could chime in and correct me if I'm wrong, was that there are many systems within systems, and the idea of autopoiesis was hinting at it is inevitable for it. Almost what I took from it was that it's inevitable for life to evolve given these certain opportunities happening first. That certain, like down to the very basic systems of like cells and cellular behaviors, like once certain chemical processes are put in order, that cellular activity will just sort of begin. Am I right or wrong or way off on that? Can anyone chime in?
Yeah, I think you're right about that. The way that I thought about it was like, um, if you have stuff, whether it's like, I don't know, like an icicle or a stalagmite or a stalactite or a crystal, like you have a certain, anywhere you have, the right temperatures and the right presence of water, you're going to have an icicle that forms. Anywhere that you have the right composition of minerals and water and, spatial structure, one of those, I forget which one's which, but stalagmites or stalactites is going to form like there at the top, and it's going to have a uniform, predictable structure based on that. So it's just like these things can't help but precipitate if the conditions for them to do so happen. Like it's more that life and all these other systems or structures that can form, like, can't help but happen once they're a continuation of something else that has already been set in motion with the placement of those conditions and the nature of the physical properties of what's being thrown into the mix.
And then so how does autopoiesis relate with that, would you say, Diego, in terms of it's kind of inevitable with these certain conditions that organic molecules will form, and then once they do, it's almost like it becomes this self-generating system that creates a membrane that then links up metabolically with other cells. And would you say that I'm on the right track? I'm still autopoiesis. I'm still like, what is it? What does it mean?
Yeah, I mean, I think that is the right track. Yeah, I think in chat, Aaron was gonna say something, but he was muted.
Oh, I'm sorry.
No, it's okay.
You're an extension of what I was wondering, actually. Thank you.
Okay, good.
Well, again, like one of the things that I always find helpful when I'm stuck on a word is to kind of look in the dictionary and the thesaurus. And in this case, Kelly and I did, and it was helpful because autopoiesis translated to auto self and poiesis creation. So I thought that was really helpful because the idea of you've got everything you need in your backpack, basically, if the backpack is the cell, right? Like you're you're like a unique autonomous collective. We all lived through that in COVID, which was true, except for we invented this Zoom platform where we could all be together in our little cells. But I think the idea of sort of self creation is kind of the idea of autopoiesis, so that within a membrane, everything one needs if one is a cell for replication and the assimilation of that which has a disturbance is within it. And one of the things that I found interesting in kind of struggling through this text 3 or 4 times this week with Kelly and others is the idea that when there is a disturbance in an autopoietic membrane, that disturbance doesn't have a singular analytic, like you can't say, well, when this happens, the result is X, because the disturbance doesn't happen on a fixed thing. So that's where the idea of sympoiesis or simultaneously or co-creation happens. So for an example of that would be in terms of an ecosystem, for example, if there's a fire and all of the things that usually stabilize the ground are damaged and there's a flood, then that flood is going to affect a mudslide more than if there hadn't been a fire before there was the flood, right? So the idea of the disturbance happening is not like it always affects something in the same way. Everything is relational to everything else. Nothing is completely self-contained. Everything is in relationship to everything else.
Yeah, exactly. That fundamental principle makes so much sense to me. And then working in the autopoiesis, understanding that there's units within these networks that have permeable membranes that are dynamic and still in deep relation, even though they have, like what you were saying, Lauren, they have what they need in their cells to continue to keep replicating and keep going. And I think that versus, you know, a rock or something that we might not term as a living entity, although that's debatable, but you know, that's kind of what these scientists were trying to work out, that living metabolism, you know, that's happening in cells. So I'm starting to feel more and more comfortable and like get it. Third time's a charm.
You know, this might be kind of like not the best way to explain it, but something that I just thought of was like, you know, to get at that cell membrane, like autopoiesis regulation, like what I thought of was, if you're a sloth and you just spend all day eating leaves up in the trees, you are going to need a great big stomach and big long arms to eat those leaves and stay up in the trees. And that great big stomach and big long arms make it so that you can't really do anything else but sit and eat leaves in those trees. And you need the stomach to break down the leaves because they're not nutritious, and you need a lot of metabolic energy diverted to it. And for that reason, you're not going to be diverting that to your other processes, so you become slow, but you can do the one thing that you need to do, which makes it so that you can't help but do anything but that. And you continue eating leaves, which means that you continue to be a sloth and be built like a sloth and act like a sloth, and so on and so forth, unless something disturbs you away from that state and you start doing something else.
Well, all I know is I love sloths, so I really appreciate that example. And their metabolism is extremely, extremely slow, right? Which then affects their behavior, and yeah.
Yeah, it is adaptation. That's, I think, like the way that I thought about it was that that's kind of what kicks off the whole process. Like you adapt to something, and at the moment of adaptation, you open up like a loop of self-regulating, self-constituting development, metabolism, I guess. So yeah, it's definitely not separated from a way of thinking about it that understands it as adaptation.
There was more imaginative process in it than just adaptation.
I think the birth or the decision of queen rearing in a beehive could be an interesting example. Every worker bee who lays an egg has, in every egg, there's potential that that egg could become a worker or a queen within the first 3 days. So if it's fed royal jelly for past the first 3 days and continue to be fed that, it will become a queen. So that's, I think, an interesting example of the environment or the food or whatever that is being brought into that maelstrom of energy in creating things. I think the queen bee is a good example of that.
I think it's important to also keep in mind that the site of the disturbance is equally crucial, because all things being the same, a disturbance that happens in one location to the exact same organism as the disturbance that happens to an organism at another location can result in two different adaptations. And so the site of the disturbance is everything. And I think that's what all of those biologists would say, is that it's a sort of it's not as uniformitarian as this discussion on autopoiesis. The structure of the mechanism, sure, is a process of symbiosis, one organism influencing another and back and forth, but a particular set of pressure, temperature, ambient conditions can influence the change in the mitochondria of a cell differently from what happens in that same cell somewhere else. And that's the incredible, endless uniqueness of life, I think.
Yeah, I think that's right on. I really agree with that, Ansu.
I also think that it's useful to step back from biology for a second and just use a physics analogy, because what you're saying about a sort of a inevitable process, given the sort of right set of circumstances, that would never have happened unless we had the very particular circumstances of the kinds of atoms that collapsed together after the Big Bang that made Earth, that resulted in a specific sort of curvature and dimension that created a specific type of gravity and pressure that allows this whole complex of life to evolve, like billions of years after the sort of creation of Earth. So that the fact that we can have a gravity itself, which is a feature of a unique set of dimensionality, just curvature and density of the Earth, that itself is an analogy for that sort of structural process that you've got going on with the cell genesis. I don't know a word to describe it. It's a magical thing to create properties and form at the same time.
Yeah, that's the whole micro to macro. It's the same exact pattern, the same system that you go all the way out. Like it's systems within systems. I mean,
yeah,
and you'd be hard put to find another. I mean, well, here's the thing: is that because we've identified this, what you've called sort of an inevitable, a property of the way that cells create life, or collapse in on themselves and then regenerate. If that can happen under the right set of circumstances, it has really helped to shift the human-centric, first of all, the human-centric, but also the life-centric notion that we have about Earth. It could happen, in another star, in another part of the universe, possibly.
Yeah, great. Thank you guys all. I mean, one last little thought is I just love what Ansu was saying because you were really pointing to thinking about context, what environment is the activity happening in and how that is in dynamic relation with entities and that being such an important mind frame to keep in our awareness as we think through these things. Jen, do you want to maybe move into show and tell?
Yes, of
moment
course.
in our
I
last
will start. Since we are talking about networks, I think this embroidery is appropriate for this. This is a mycelium network carbon exchange. And I have to tell you, I've had so much fun doing this. I'm definitely not done, and I was thinking of you, Alan, because as I've been going through this, I'm like, I'm gonna color the inside a color, but I haven't decided what. My mind keeps going from like, maybe I'll do green, or maybe I'll do a lilac. So we'll see next week because I'm almost done with like this outer section here, and then I'm gonna kind of do the interior, and then I'll do this ring around the edge of it. So, I. As I said, I'm Jen. I'm calling you from Studio City, and I use she, her pronouns. And this is my Mycelium Network Carbon Exchange. And I will pass it to Cindy.
Hi, I'm Cindy. I'm calling in from West Covina, and I just finished my embroidery, so I've turned that into Jen. So I just have this meal fat that I just started. It's just the leaf, but I think I might change it to one of the underground patterns that we have. That seems a lot more interesting than the meal fat, although it's beautiful. I will pass it on to Jill.
Hi, I'm Jill. I don't have an embroidery that I'm working on, but I can share with you the kitty cat. Just to say hello.
Adorable.
Enjoying the conversation. And I will email in to get my embroidery, but thank you all for having me. I'm in Koreatown, and it's nice to be with you. I will pass it to Millie.
Hi, everybody. I'm Millie. I'm calling from Glassell Park. My pronouns are she, her. And tonight I was giving life to some old overalls. I was mending. They were falling apart. So I figured a good time to listen and mend these back together for another life. I will pass it to Lauren.
Hi, everybody. Lauren, I'm using she, they pronouns. I'm calling from Paya Hunadu, so-called Owens Valley. I'm working on an underground pattern from the microscope. And I will pass it on to Walker.
Hello, I'm Walker. I'm presently in Baja California, where I live. And I just started on some kind of weird organism pattern. I don't really know what it is. It's completely fantastical. And it's just beginning.
Ooh.
And I'll share my dog with you because I know Lauren wants to say hi to her. Hey, Critter. That's enough lap for her.
Hi, Critter.
Too busy with her ball.
Got a popcorn at Walker.
There you go. I just wanted to share one other thing that I thought was interesting was this giant bundle of embroidery thread that I found at the thrift store. That's like a big mess, but it's every color you can imagine. So I'm excited about that. I have more than 3 colors now.
I had that experience with finding embroidery thread at a thrift store like 10 years ago that just sat in my room, and now it's got all the use in the world. That it's all set up with like cards for different projects and everything.
That's an impressive embroidery lost library. We're gonna come to your place next.
Wow.
That is completely pro.
I'm so glad I get to use it.
I'll pass. Who didn't? Millie spoke. Who else? Roxanne.
Hi, I'm tuning in from West LA, and I'm working on Common Raven.
Beautiful.
And I also mended a dress. And I use she, her pronouns. And how about I pass it on to Wai-Yin?
Oh, hello. I'm just listening in today.
Okay, so I will pass it on to Ansu.
Hi, I'm Ansu. I use she, her pronouns. I'm calling in from where am I? Silver Lake. And I got this lovely thing in the mail. Thank you, Cindy or Jen. I don't know who it was. So I'm not sure what this is. Is this the one that's underground?
Can you hold it a little bit closer? I'm having trouble seeing it. Oh yeah, that's the nematode. Nematode and Friends is that one's called.
Nematode and Friends. Love it.
Lights and things. Yeah. I'm going to pass it to. Hold on. Let me try to find something. Donald. Donald Bradley. No. Or Laura. No. Okay. Michelle. Or Mikkel.
Michelle, he, him from Highland Park. This week, the reading was a bit more difficult to me, so I really plunged into sketching. I started to work on stars and ants, and this week I was lucky because we got a lot of graphics. So I just started this that you might recognize. It's very quick. And then also I got this, and then I got that.
Beautiful.
That's what I finished from last week.
Wow.
And thank you. And I will give the mic to Dee.
Hi, DeRainer calling in from Baldwin Hills, and I go by she, her pronoun. I'm working on the yellow roof bird. Still working on it. And I am going to try to do the letters so I could get extra points.
Yes!
10 points are important.
Looks kind of difficult to do, but I'm going to attempt to do that.
You got it, Dee.
I will pass it to Covey.
Hi, good evening, everyone. We use he, him pronouns, calling in from Sacramento. Today, I'm working on the hermit thrush. Admittedly, this is my first embroidery, so I'm taking a little slow, having some fun with it. Last session, I spent untangling a big wad of floss and got frustrated with it, so just decided to listen in and really enjoy tonight's readings as well. Hopefully I'll get better at this, and I really want to finish in the next couple of weeks. I've been hanging on this since the last series, so hopefully I get to do some embroidery outside of these meetings as well. And I'll pass it to Kelly. Really admiring the fiddle leaf behind you.
And before you take it, Kelly, I just want to give you a little tip. All you have to do is because I was getting mine tangled up too, don't make the string longer than like from your hand to your elbow. If you go any longer than that, that's where you run into a whole bunch of problems. So that's my tip for today. Go ahead, Kelly.
Hi, Kelly. I use she, her pronouns. I'm in Echo Park. I just started the yellow rumped warbler and manzanita. So very, very basic. I got a few twigs in, so stay tuned. I'll pass it on to Marianne.
Hi, I'm Marianne. I'm in Silver Lake, and I'm waiting for my kit to come and looking forward to doing the embroidery when it does. I just did a little bit of writing today as I was listening, and it's wonderful to be with you all. Thank you for sharing. Pass it. Let's see. I can't see everybody very well.
Well, I think most people have had a chance, and we're about at end of time. So I'll just thank everybody for coming and working through these texts. I know they can be a bit challenging, but they're intriguing too. And I'm enjoying pushing myself next week. So we want to invite you back next week because we're going to be looking at symmetry, spirals, emergence, growth, and chirality. So just to intrigue you guys to come back.
How do you spell that?
It's CHIRALITY. Chirality?
That one.
I think that's how you pronounce it.
Chirality. Yeah, that is it.
Great.
Okay, thank you. Thank you guys. So
Thanks,
that'll be great. And thanks everybody. Hope to see you.
Everyone.
Thanks, everyone.
Good night.
Thank you. Bye.
Good night. Thank you, everybody.
Bye, everyone.